All right, welcome back to the notes. So this week we're going to talk about atoms and isotopes, and we have a good week ahead. So we have a test on Friday, and you're going to want to make sure you know all about the stuff we talked about this week with protons, neutrons, and electrons, and how to find the number of neutrons and protons in an element. And then you're also going to want to make sure you know what an isotope is, because not only are we going to have a test on Friday, but this week on Wednesday we're going to have a project, and so it's going to be using that knowledge that you get on Monday and Tuesday on Wednesday so that you can do your project. So we're just going to learn some basic information today. So a quick review on what's important about atoms in order to understand isotopes. All right, so remember, atoms are made up of 3 particles, and we can call them subatomic particles, and that's protons, neutrons, and electrons. So subatomic just means it's smaller than the atom and it's inside the atom, and so these are the 3 main things. Now, one question that is review, but we want to make sure we really know what it is which of the 3 particles identifies what element an atom is. So basically these 3 particles at the top, which one determines what element you have in your atom, what atom you're looking at. Is it carbon, is it oxygen, that kind of thing. So take a second, think about what it is. All right, hopefully you said protons. So protons are what determines the type of element. And we know that because we have the atomic number at the top of the square. And if the atomic number changes, so does the element. So if you have 1 proton, atomic number 1 is hydrogen. But if you have 2 protons, it's helium. 3 protons is lithium. So every time our number of protons goes up, we get a different element. So that's how we know that. All right. So in any element, the number of protons never changes. Okay, just said that. So if we have 2 atoms of carbon or 50 atoms of carbon, all the atoms are going to have 6 protons. If they don't all have 6 protons, then they are not all carbon. Okay, so we can, even though we can't change the number of protons in an element, we can change the number of electrons and neutrons, and it can still be the same element. So, for example, carbon always has 6 protons, but it could have anywhere from 6 to 8 neutrons, and it could have anywhere from 2 to 10 electrons. So just because an atom, 2 atoms might be the same element, they could have different numbers of neutrons and electrons depending on what's going on. But they cannot have different numbers of protons, or they're not the same element anymore. Okay? Now, an isotope is an element that has a different number of neutrons than a normal atom of that element. When we say normal, we mean that what you see on the periodic table, and we're going to talk about this in a second, what you see on the periodic table is an average of the element. So when we say that carbon has a mass of 12, that means that when we take all the carbon atoms and we average the masses, it equals about 12. All right, that's how we get decimal places sometimes. Okay, so if we take all the hydrogen atoms that we know about and we average them together, then we'll get an atomic mass of 1. Okay, so when we say a normal atom, we mean what we would find on the periodic table, which is an average. So carbon, for example, we've been talking about carbon the whole time, has 3 isotopes. All right, there's carbon 12, carbon 13, and carbon 14. Now you notice that all 3 carbons have 6 protons, but they all have different numbers of neutrons. So that's why Carbon-12 has 6 protons and 6 neutrons. So if we add those together, that's how we get a mass of 12. Carbon-13 has 6 protons and 7 neutrons. So 6 plus 7 is 13. And carbon-14 has 6 protons and 8 neutrons. So 6 plus 8 is 14. So those are all the possible atoms you could have of carbon. You could take one carbon atom and it might have 12 protons. You could take another one, it might have 14. Not protons, I'm sorry. A mass of 12. You could take another atom and have a mass of 14. And then another one might have a mass of 13. Okay, so that's why if you look at the periodic table, you'll see the mass of carbon is 12.011. That's because there's a lot of carbon atoms that have a mass of 12, but since we're also averaging that with 13 and 14, it's going to end up being a little bit above 12. Okay, so I know it's a little heavy to think about, but that's how they come up with that. All right, so most atoms have naturally occurring isotopes. Some examples are radon, potassium, uranium. They all have naturally occurring isotopes, so we don't have to make them in a laboratory. We don't have to take an atom and actually insert a neutron or take out a neutron. They just happen on their own. We can find them in nature somewhere. All right, when an element is radioactive, it means it has an unstable number of neutrons, which would be an unstable isotope. So if we see that boron is radioactive when it has 7 neutrons, then that means it's unstable with 7 neutrons. So we would have to add or take away neutrons in order to make it more stable. Okay, so when you see that radioactive like we saw in our gizmo, we hadn't really covered what that meant, so we didn't really talk about it, but that's basically what it means, is that it's unstable. We need to change the number of neutrons in order to make it more stable. And then lastly, the elements as they are found on the periodic table. So when you look at the periodic table on the wall or in your book, those are neutral atoms, and their mass is an average of all the isotopes. So that's what we just talked about. The ones on the periodic table, they're neutral because they should have the same amount of protons and electrons. So we know boron has an atomic number of 5, so it has 5 protons. So we can assume that if it's on the periodic table, it's neutral, and it also have 5 electrons. And then we know that the number of neutrons it has comes from averaging the number of neutrons for all the isotopes of boron. So if there was boron 6 and 7 and 8, we would average those together and get the one on the periodic table. Okay? So hopefully you learned something about the periodic table and about isotopes and about atoms, and we'll be going through this mainly on Monday and Tuesday. And Wednesday is going to be more of a project and researching and looking stuff up about isotopes. And then Thursday is review and Friday is a test. So make sure you are ready, and make sure your binder is ready for another binder check. See y'all later. Have a good weekend.